SwayamPrabha. Digital India. Educated India.
Hello and welcome to this Manufacturing Systems Technology Part 2 course, Module 2. We were talking about the costs of quality in the last module, and let us look at why costs. So as we already know that one important aspect of product development is really to translate the need of the customer into the product specifications. Okay, so the customer requirements, you can say, into the product specifications. So the manufactured products which do not meet the specifications have to be necessarily repaired before giving to the customer, so that they can start meeting the needs and the aspirations of the customer itself. So the prime quality costs for supplying the satisfactory products to the customers include producing, identifying, avoiding or repairing products that do not meet the customer requirements. So obviously, if you introduce quality at the process stage itself, by designing the process in a way that it produces high quality, then there may not be many deviations, okay, and this quality cost would come down. So there is some kind of a penalty matrix that you are associating with every non-conformance stage which is happening through the process control or even at the product design stage, okay. So, and this cost has to be overall minimized, which are also known as quality costs. Costs in order to ensure that whatever is the output of the process is meeting the customer need. And this can happen only if you do process improvements and process balancing at every stage, so that you have zero defect produced from the from the process, and zero non-conformance of any kind of standards or quality framework which has been laid out. Okay. So the goal should be really continuously to shift the endeavor towards a value where these costs come down to minimal numbers. And let's look at some of the costs which can be categorized into many different categories. So there are prevention costs, and I'm going to give a brief introduction about these different costs, maybe do some calculations at certain time to figure out how these costs can be attributed, and how quality losses can be sort of minimized by doing process design, etc. There are appraisal costs, okay. There are internal failure costs and external failure costs associated with the product. So let us look at some of these different categories and what they really mean. So the prevention cost includes all efforts that go into designing and manufacturing a product that meets customer requirements by preventing non-conformance. Okay, so you introduce checks and balances everywhere. For example, while the product is being designed or the process is being designed, we have to have enough scope in the design for quality planning and quality engineering. Okay, so this may at the outset seem to be a non-value added activity, but it's important because when you are laying out a process with a certain specification, the conformance to that specification is an absolutely important aspect for repeating the process again and again to produce many products. Okay, so there are various elements of prevention costs, which includes activities involving, let's say, quality planning and engineering. In all organizations there is a quality systems department or a quality engineering department which actually does process audits, which does product audits, all those different things to ensure at every level that there is some kind of a non-conformance. So this has to be in the part of the design of the organization. You have to put these components which are additional costs which you are trying to impose, which will rather prevent the the non-conformance to standards or specifications. Okay, so this is a sort of a futuristic activity that is being planned at the design stage itself of the organization, so that you ensure that there is repeatability, although it may not seem to have an immediate return when the process layout has been done, etc. Okay, but the deviation happens because it's a dynamic machinery or a dynamic part or a dynamic system, and these deviations have to be kept within control. Okay, so you can also have prevention costs by, let's say, new product reviews, For example, what is the perception or the need mapping of the customer, or even the aspirations of a customer behind a certain product. Customer thinks X, Y, Z different things about a certain line of cars, for example, or a certain line of automotives, for example. So the reviews would be able to sort of get incorporated at the design stage itself, so that there is enough quality and that need can be somehow mapped. Okay, so that's also a prevention cost of things in business to be meeting whatever the customer wants, and the ability of the business to change itself completely dynamically, so that that mapping can happen at every level, is a prevention cost. Okay. Product and process design is a very, very important issue. At every stage, you will have to have process control, you will have to have training, you will have to have quality data acquisition and analysis. So these are additional costs which are imposed on the system, although there may not be any direct value added to the product, but just to ensure that there is no non-conformance, this prevention of quality non-conformance, or prevention of inappropriate quality to happen. So these are indirect costs which are bunched onto the system. So that's what prevention cost. Prevent non-conformance and cost associated with preventing that non-conformance. Obviously, there would be an appraisal which is needed at every stage, which includes measurements. All quality parameters are somehow subjected to a thorough check in terms of some measurements. For example, the diameter of a shaft may be 1 inch plus minus 0.03 inches. So this is a dimension and a tolerance given in the design itself, and the process should be able to meet these guidelines as it produces. And so how do you know that the process is meeting the guidelines? Obviously is by measuring the output diameter of the shaft which is coming out of let us say a CNC lathe, okay, or some kind of a process which produces this turning. So all those costs which are involved in measuring, evaluating or auditing, and this appraisal cost comes into picture because of the prevention in the design itself. Okay, so you have a scope for quality aspects or quality auditing or quality data acquisition at the system level itself, which imposes these costs. Okay, so these come because you can actually try to validate the components which are coming as raw materials in your system, the purchase material, to ensure the conformance with the standards and the specifications before feeding it onto the system. So these are additional appraisal costs where you're appraising, you're trying to measure, you're trying to evaluate the standard, compliance of the particular part that is going through in the flow in, flow out system, okay, of the process. So these, most specifically, the appraisal cost would include cost of activities related to inspection, test of incoming material. There is, for example, a parts inspection cell which is always there when we are talking about vendor development or supply chain management systems. So the parts inspection goal here is to sort of see that if you are having two sources from which same part is coming, are both the sources complying to the standards laid out, and if there is some kind of a deviation, then the PI or the parts inspection has the responsibility, added responsibility, to go and do a process audit at the vendor end and seeing what is the reason for the non-compliance and trying to remove that, so that that comes realistically into the system and the system doesn't get altered much. So you have product inspection and tests, materials and services consumed, and maintaining accuracy of the test equipments. These are all a part of the appraisal cost. There is an internal failure cost, which means that this is related to when the product is in the production stage itself and it has not yet gone to the customer. So it has not yet gone from the purview of the production unit to the, let's say, the dealer or the customer, and this is a huge amount of saving if you have a little slightly more internal failure cost. Obviously it has to come down, that is going to be the basic philosophy. Then the external failure cost. So you have to in any event ensure that the internal failure cost may be sort of higher, so that the external failure cost doesn't come at all, because that actually is related to the perception of the customer about the company, and that perception is something that you cannot lose, you cannot afford to lose that. So internal failure occurs when products fail to meet customer quality requirements before being shipped to the customer. Examples may be something like failure analysis, scrap repair, retest, downtime, yield losses, downgrading of usual specifications, sometimes which happen because of some constraints and some meeting of the lead times, production lead times issues. There is a lot of pressure to create parts or create systems which are non-compliant to overall standards sometimes, and then later on not leave them within out of the purview of the production, and when the right tuning is there, you can probably replace some of the components there, so that you may be able to get them back on track in the quality standard which has been laid out. So for example, let's say in a production line in cars, you may have a concept of because of the unavailability of a certain material which is of critical importance. Let's say for example, there is a tire, automotive tire, and it is unavailable on the line. So you can mount a different tire which is available, or a different grade of tire which may otherwise not meet the specification, and try to ensure that the production is smoothly done, and before dispatching it to the customer, try to do the changes and the quality inspection therein at that stage, so that some rework is done, so that there is a compliance, overall compliance of the guidelines or the specifications laid out. So these are also a part of internal failure cost. Sometimes the management does need to take decisions where, because of the some kind of unavoidable consequences related to a certain aspect of the process, the overall process should not get jeopardized. So there is a conscious decision making which is involved in that case, but then again it's an internal failure, and that cost gets accrued onto the overall product cost. Obviously it is much better than getting an external failure cost, which is when the product do not function satisfactorily after being supplied to the customer. Okay, and this is something you cannot afford. These days the companies really are hell-bent on, I would say, arresting the warranty issues which come from the market, and each and every warranty complaint is treated very severely at the level of the quality engineering or the quality systems management group of a particular company, because that is something that one cannot afford, because this really creates a pressure on the customer's mind to change his decision about buying that particular product, and this is something that is essentially amounting to losing business. Okay, so therefore external failure costs by and large should be avoided, although there are certain issues which would happen with time. For example, when there is a dynamic machinery and it is trying to be used, or it is being used for a very long time, for many cycles, there is bound to be some deviation in the particular machinery. And this deviation is something which eventually will result in some kind of a failure. So therefore people really look at maintenance plans and forced maintenance plans. Sometimes the manufacturer provides forced maintenance plans just for this reason, that your compliance to the standard, even if when the product is performing with the customer, should never go out, and the customer should have a good perception of the product all through the product lifetime. Okay, so that's what mostly these companies are intending these days, that once it is sold to the customer, the liability of the failure also is partly owned by the company. And so these are major costs which are incurred for activities such as complaint adjustment, dealing with returned products, other costs like warranty charges, liability costs, etc. by and large should be avoided and should be limited to the internal failure cost level. So this is what is the cost structure for ensuring that there is a quality system in place on deployment. The other issue is overall, there has to be a framework where you have this quality improvement at every stage of a particular business, and the quality has to have its presence in all the different phases of the product life cycle as such. You know that the life cycle starts with the product design stage, then with the production process design stage, the actual production stage, and then the maintenance and the product service stage. So these all four formulate a part of the product life cycle. So there has to be a presence of quality in all these four stages related to the product life cycle, and you have to build a framework so that there is a possibility of improvement quality wise at every stage of this product life cycle, so that you can build the right quality, the right quality at the design stage. Okay, so somehow the cost of quality control and production stage can be considerably reduced because of the quality by design, and also the preferable approach to improving the product quality is to build quality into the products at the product design stage, so that again the overall cost of maintaining the product compliance is reduced. Okay, so typically these two stages, design and of the product and the design of the production process are very, very critical, because this would allow you flexibility to change the overall guidelines, the envisioning system plan, which would ensure that everything is compliant. Okay, so the flexibility can be utilized at the design of the product or the design of the process stage itself. So this brings us to the end of module 2 of this manufacturing systems technology part 2. We will talk in the future modules about how to design the products and process to ensure full compliance of the quality. So that will do in the subsequent module. Thank you.